I'm David Beckingsale. I'm the director of the Radius project, and I also lead the research software engineering group that's in the Center for Applied Scientific Computing at Lawrence Livermore National Lab. And today I'm going to talk a bit about growing a community at Livermore, kind of from the inside out. So what is Radius? It's a really large institutional project that Lawrence Livermore funds to try and broaden and share a common open source HPC software stack. So these are the products that are developed internally at Livermore but released open source. It's funded as a broad kind of community program, so it's not just money for software development, like adding features and stuff like that. We try and do things like provide RSE time to projects that are interested in working with us. We have targeted sustainment of a core collection of these open source libraries, and we also do some engagement activities. So I'm going to go over three main things in this talk: how we try and organize this support so that people feel comfortable adopting the products that we're kind of promoting, how we can turn policies and some surveys that we've conducted into kind of real change, and how we apply some of these ideas to a real application at Livermore. So I think the default for a lot of teams in a large HPC organization is that they'll adopt dependencies solo, or they'll go and re-implement everything. I'm sure you have seen however many different I/O libraries people have. Everybody wants their own special flavor, and you end up with a lot of duplicated effort, whether that's hardening, fixing bugs, CI things, system build problems. Teams aren't sure who really maintains a library, if it's just randomly pushed up, either on GitHub or in some, internal website. Getting onboarded, and starting using one of these can be quite challenging. A lot of knowledge ends up being kind of institutional and it's not well documented. And when external contributors come and look at these projects, they just don't really know, where to start. The environment is too complex. And really what I would say is this really causes, slower scientific advancement because, it's just taking more time to get this stuff working. There's a higher cost for sustaining all this duplicated stuff, and the quality across projects can be really inconsistent. So as a picture, Radius kind of looks like this. We have these three pillars that I'll go into kind of more specifically in some of the other slides. We have one thrust where we're looking at funding kind of community building, supporting projects with hardening, developing tutorials, improving their documentation, and doing outreach. We have one thrust where we help other applications at Livermore that maybe have less kind of programmatic support adopt some of these projects, and we provide both research software engineers that can help with that, as well as funding for people on those project teams to kind of learn and come up to speed on the things that we're promoting. And the final piece is kind of this infrastructure, trying to create some common tooling and templates and stuff that people can grab and get started, right? And we're trying to kind of turn this whole stack into core infrastructure in the same way that you might view your compute facility, right? So what Radius as a community program kind of means in practice, it's not this mandate or some list of libraries. What we try and do is invest in people. So whether that's as I said, the kind of dedicated research software engineers who can work with teams, or actually going in and helping people on those teams themselves, give them funding, which effectively means they have time to learn and come up to speed on these things. We have process, so this is focused on engaging with these application teams, as well as working with a kind of a core portfolio of open source projects that we promote. And then we also have a platform piece, as I said, which is this kind of shared CI, build patterns, policies, documentation, to try and stop people from having to to reinvent the wheel on every single project to kind of have this base level of kind of software quality that you might expect. So we help, teams adopt these, both the kind of infrastructure piece as well as select projects from our core portfolio that kind of fit their use cases. And we really focus on teams at Livermore that don't have this huge base of programmatic support. So some of the things we do to help developers adopt tools, as I said, we have targeted engagements from research software engineers. So this is not just saying this person's going to work on your project at half time for a year, right? We're much more specific. We identify a particular issue that they need help with, something that's been very common, popular over the last few years has been helping teams come up to speed, getting their code running on GPU architectures. So it's been a common engagement, but it's really targeted. It's not just adding another software developer to a team. We've conducted a few surveys over time to really try and take the temperature of what people are struggling with, and then turning those responses into actual kind of actionable items that we've been able to feed back up the chain and try and affect some change. And then the infrastructure that we provide, as I've said, we're trying to make the right way to do things the easy way. I'm sure you can imagine there's various compute platforms have their own intricacies and complexities, and if you know the ins and outs and one person finds some weird bug and they fix it, it's best if we can fix that in one place and have a bunch of other projects use those templates for doing their builds. And we've also done some SPAC configurations in the same vein. We will meet with application teams, these large applications that are well supported, find out what configurations they're using, what compilers, what dependencies in particular versions, and put those in a central place, both so that we can then test our core portfolio of projects using exactly the same configurations. But if somebody's wondering what compiler version should they pick on a particular system, we have something that we can point them at and say, this is something that we know people are using. So I think this slide tries to capture what it's like to get or to convince people to adopt these shared dependencies. As I said, everybody must have seen teams just writing their own version of whatever feature they need, right? Because they have this visible technical risk that I think is easy to communicate to stakeholders, right? You can say, oh, it's kind of, too difficult to adopt this dependency and we're not sure why. But I think really what's lurking beneath the surface are the real reasons that people kind of shy away from adopting these things, right? They're not sure who owns a project, who's going to sustain it, who would pick up the phone if they try and use this thing and have a problem. And so one of the things that we really focus on in Radius is to make it, people know who supports this library, and it's easy for somebody to come and pick it up, and Radius will provide the people to answer the phone if they have some kind of a problem. So we have some shared policies that we've tried to encourage, and I think these help make packages more attractive for projects to adopt. So there's things like picking a permissive open source license, having some kind of expected norms for how you should build and package the project. So primarily the portfolio of libraries that we promote are C++, so we encourage people to use CMake and SPAC for their kind of build and packaging. We have expectations around, people should be testing. They can use the Radius CI infrastructure if they want, so we try and make that easy. And these projects have kind of clear contribution processes, most of them using PRs on GitHub. And I think the kind of final thing, again, going back to the infrastructure, is we provide these kind of easy on-ramps to using this stuff with CI templates that you can kind of plug and play with any project, and you can reduce all the kind of duplicated engineering work, as I said, kind of dealing with all the different idiosyncrasies of the various systems and stuff like that. And again, we provide these SPAC configurations to help consistency across other projects, and give people confidence that if they're going to try and build on a particular system, they're starting from a good place. So moving on to the policies, this I think is something that can be quite challenging to implement in practice, and I feel like we've kind of done a reasonable job with this, right? That it's very easy to send out a survey. I mean, the first challenge is getting people to actually answer it. And if you can do that, then the next challenge is turning that survey into something more than just a report, right? You want it to turn into some kind of action item, and normally you're kind of trying to push these requests kind of up the chain, so it helps to have strong evidence as to why these things are kind of useful and desired. Having policies, they often can look a bit like gatekeeping, or people will just go through and do the bare minimum to check them off. I think you saw on the previous slide, some of the policies we encourage are not, I don't think, are too onerous, so I think that works quite well. And if you do a survey and you don't turn it into something actionable, then everybody who's answered your survey just feels like it was a complete waste of time, right? So I think it's important to turn these things into action so that people trust that their responses are taken seriously. So yeah, we conducted a developer survey a few years ago, and we tried to understand the kind of practical needs that developers at Lawrence Livermore had, whether that was tools that they wanted, various resources, things for their development environment, as well as the more intangible things about how, kind of how they felt, how excited they were about working on different things. We got pretty broad participation. We had both, kind of easy yes/no type questions, as well as, a bunch of open-ended feedback, which, I would admit can be risky, because oftentimes when I fill out a survey and I see an open-ended text box that's not required, I'll probably just skip over it. But we did get quite a lot of good feedback. And kind of going back to this idea of turning it into action, we really focused on being able to close the loop, and we reported back to people what we actually did based on the feedback that we got. So one thing that I think was interesting, and this was a few years ago now, but VS Code was becoming more and more popular, and that was a clear thing that we identified from all the responses. And then we kind of were able to share that internally and try and encourage the compute center to make it easy for people to use VS Code where they were doing development. And this also fed into enabling some of the kind of web IDE features on GitLab, which is what we use to host code internally. Okay, so to move into a quick kind of vignette of how we've applied some of these practices to a real application. There's a code called GeoSex, which is a subsurface simulation code, some multi-organization collaboration, Livermore, some universities, as well as industry partners. And they adopted some of this Radius core portfolio. So, they needed science, they needed portable code, portable high-performance code that was going to be sustainable. And so they kind of built around some of the core tools that we encourage people to use. So I think the ones you're probably most likely to be familiar with are Rajachai and Umpire, which is a kind of programming model that provides a kind of performance portable abstraction for C++ code in a similar vein to Cocos. So I think some of the things that I would take away from our engagement with that team, were to get people contributing. I think it's important to have a pathway that makes it easy for people to get the code up and running, and that documentation has guidance on how to use SPAC and ubrem, which is kind of a wrapper around SPAC that handles some common use cases. It's helpful to have clear norms around contribution. Some of the policies, like I said, we don't try and be too militant with them, but we really encourage, transparent pull requests, issue-based communication around problems, with documentation expectations, CI testing, and we have points of contact for the different projects, and it makes it obvious, for a newcomer where they should go and who they could talk to. And I think that the thing I think is the most valuable and what I'm kind of most proud of is that we have this shared ecosystem, right? And the more people that buy into using these tools, the more value that gets created, right? You don't have people wasting their time re-implementing something. They can focus on their unique capability and put all their energy into that without having to worry about, is their code going to compile on a CUDA machine and a HIT machine, or all that kind of stuff. So to try and turn that into a bit of a playbook, the lessons that I think we can take away from Radius. So I said at the beginning, we don't just give people money to add new features to their projects, right? It's more about sustaining, helping them engage with other people. We have a bunch of shared infrastructure that makes it really easy to do the right thing and give people an on-ramp to adopting these tools. We have signals that make it obvious to people why a particular project is safe to adopt, right? So who owns it, that it's being tested and the tests hopefully pass, and the builds are reproducible. We did a lot of work, taking surveys, but then actually turning them into, some kind of action, which I think, as I said, is very important for building trust with the developers. And we have various kind of on-ramps for how people can interact with both the Radius infrastructure projects and some of the core portfolio of libraries that we are promoting, right? Whether that's documentation, issues, right? People know what to expect when they engage with these projects. So I think some of the issues that you can run into trying to stand up a program like this is that, mandating people adopt shared components without having the capacity to support them is a big challenge. We're very fortunate that Radius has a large amount of funding to be able to sustain these projects and to help people that choose to use them. Kind of doing drive-by consulting is another issue. When we engage with applications, we make it very clear what the target is going to be, and it's over some length of time, but we kind of have this answer the phone promise that's kind of ongoing, right? Not funding maintenance activities on projects and expecting the community to grow and take care of them. I think that's probably a pretty obvious one. Using policies as barriers rather than suggestions, and trying to help people improve by adopting them. And I think I've harped on this a whole bunch already, but having per project infrastructure or per project libraries, and letting people kind of get away with it and say that their needs are so unique and it's more flexible to implement one-offs all the time. And I definitely don't think that's the case. Okay, so it's my last slide just to kind of reiterate and think, I think what we're trying to do is build an ecosystem and a community around these projects, not just provide some kind of a tool chain, right? And I think it's important to organize support around these projects so that people can feel safe to adopt them. They're not worried about what's going to happen. If you're going to try and take surveys and you're getting feedback from developers, it's important to turn that into something actionable that they can actually see you care about what they say. I think the final thing to kind of a takeaway from the Geo story, right, is to make it easy for people to contribute, and you can kind of see how all these pieces can fit together and allow a domain scientist that's working on a complex scientific simulation code like that not have to worry about some of this core HPC infrastructure and focus on what's really important to them. I think just my kind of final statement would be that over time, I've started to kind of view community building as infrastructure itself. I've got plenty of time for questions. Thanks.
It's a very cool talk. Thank you. Could you talk a little bit more about some of the questions that you ask in the developer surveys? Because you did mention you didn't want to leave a blank text box. So how do you have like enough structure, to get thoughtful answers, but not be like over constrained that, and have a set of consistency? Because I think you mentioned you'd want to do these every few years. So questions that you'd want some staying power on, or.
Yeah, we've iterated. The first survey we conducted was much more checkboxy, and it didn't focus quite so much on like the developer experience. And then we tried to make the next survey more like that. I think the one thing, well, I can share. There's a published report on the kind of outcomes of this survey that Vanessa Socket wrote, and I can get you that link. I think one thing that worked well when we were putting the kind of questionnaire together was alternating between like easy questions and hard ones, right? So if you've asked, I don't know, ask somebody their favorite text editor, right? That's easy to fill it out, and then the next question might be more about some of those intangible, like how do they feel about the way open source is supported, or things like that. So yeah, hopefully that's a helpful answer.
Yeah.
You mentioned that you focus a lot on some of the smaller teams that don't have an enormous amount of infrastructure support and such. And I think that's really important because those teams often just make things work otherwise in ways that aren't the greatest. But there's also a lot of synergies that can be obtained by working with some of the larger projects, and they may be reinventing your wheels. So do you cooperate with the infrastructure teams of some of those larger projects, or have a similar tool base, or is it pretty much completely separate?
Yeah, great question, thanks. So I think that we try and make sure we're aligned with what they're doing. And one thing I would say, kind of in relation to these larger projects, is a lot of this kind of portfolio that we promote, so like Raja, for example, was primarily developed by one of, some of the larger code teams, right? So we're kind of taking projects that were developed primarily with a large kind of injection of programmatic support and helping other teams use them.
Thank you. Yeah, so I was interested in your point about the software dependencies and how, hard that is. And I'm wondering, do you use any strategies focused on the team of people, helping them establish dependencies, interpersonal dependencies, and does that help with software dependencies?
That's a great question. I think it definitely would. It's not something we've done. I think I'm maybe technical to a fault, and so I would always attack something as a technical problem. But yeah, I could certainly see it being addressed as a kind of a social issue.
You talked a bit about signals of like adoptability for a project, and that's something that we've talked about a lot in a slightly different context with the life cycle of HPSF projects. Can you talk about kind of what you've learned internally at Livermore doing that could maybe be applied more broadly?
Yes, I think I would have to think a lot more to answer that question. Yeah, no, that sounds good.
I don't know how to ask this question, so I'll just be very blunt about it. I have concerns with GitHub, and you called out GitHub directly. Do you have any comments on that, I suppose, of what, I think maybe there's a better alternative out there than GitHub specifically. I'm not sure what yet, but I have concerns.
Sounds.
Please be a little more blunt. GitHub's uptime is suffering. I'll go with that. It's a downward trend, and there are definitely within the fringes of the open source community, there's concerns about the direction it's taking and its focuses.
I feel like this could be like the editor question. We've not considered it. No, I think that's where a lot of the projects have been open source for a long time, and they've been on GitHub for a very long time. And I think especially trying to encourage people who aren't involved in this kind of community to go out and like, this is where you get software from. It's not, you don't get a zip file from like emailed to you anymore. So I think just kind of going for the most recognized name helps in that case.
So I have several. I'll try to keep them as simple. The first one is this primarily applied to the open source projects at Livermore, none of the internal only facing ones?
Yes, our engagements and stuff like that. For the infrastructure piece, we try and align with what they're doing internally.
Okay, that
But we could probably talk more one-on-one, I think.
I'm happy to. The more important one, I think, is you had a phrase on there that I liked about bespoke infrastructure. Have you had occurrences of teams wanting or claiming to want generalized infrastructure and then later wanting to exercise more direct control over, for example, we need to use this specific compiler version that has to be different than everybody else's because of X? We've seen this on a similar Sandia effort, and I worry that the way that management sees this and leadership is kind of like a rent-a-DevOps effort instead of a unified infrastructure effort. Have you had similar experiences or no?
We haven't, but I think that's primarily because of the kinds of teams that we kind of engage with. I would suggest maybe that you talk with Chris White, because I think...
We don't force compilers on anyone to use the language systems. Whatever compiler you want, you can move your
Yeah, so I would say like the spat configs and stuff that I talked about, there's a lot of compilers, very similar versions, but you have to have two whatever versions of compiler that are very close for whatever reason, and that kind of stuff. So we do have that.
Just a last quick question. Do you think this model you presented can scale beyond one single institution that's quite corporate in its way of functioning?
Maybe. I think the thing that I've thought about more is using this kind of model almost like a franchise and having multiple radii that are maybe focused on specific things. So I think I could see doing that per institution and then maybe having some coordination above that.
I guess I have one last question. You said that you have all these configs and you have lots of different versions and there's still a lot of variability. Do you find that the fact that you have just written them down and that you have a template for people has made it easier to drop some over time as people see that other people are using, say, the one patch version further of the compiler successfully?
Yeah, I think it's helped, but it's not a technical issue, right? It's a political, I guess.